Okay, hello guys. Today our topic is about the quartiles and the spread. Okay, so let's move into the first part about it. Okay, so here let's move into the introduction to quartiles. Okay, so here we can find in the graph we have basic different data right here. First, we have minimum and maximum. For example, like we have 1, 2, 3, 4, 5, 6. So we can say 1 is the minimum value among the six numbers, and 6 is the maximum numbers among all the six numbers. Okay, that is it. And then we have median number. So we said median means at the central places, right? So we can say maybe for here, 1, 2, 3, 4, 5, 6. The median is for 3.5, right? That is the average or the mean value for 3 and 4, okay? That is the mean value. So we can also using a Q2 to represent for this. And then we have lower quartile and upper quartile. So we consider as now lower quartile is 25% distance near to the minimum and another 75% uh, away from the maximum. Okay. So here we can say here we have six numbers. So two you can find here as maybe for like 2 or 3. Here is just from a very low distance between the minimum, and then this place is just 25% to the maximum number. Okay, six. Then just consider it as you're dividing your data into four parts. Like lower quartile is a 75th rank in the total values of your data, okay? And upper quartile is a 25th or first 25th or 25 percentage among your all data, okay? That is a basic introduction to quartiles, okay? So we can say here, lower quartile means the 1 over 4 times n plus 1's value, and median means a half times n plus 1's value, and upper quartile means 3 over 4 times n plus 1's values right here, okay? So then let's try to find it together, okay? So also we can set a new word called interquartile range. That means the upper quartile's value minus the lower quartile's value. You can say it's Q3 minus Q1 right here, okay? That is it. So here, also we can just using a box and whisker plot to represent for this, okay? So here we can set like we're using a maximum value minus a minimum value right here. And then median is at the central right here, okay? So we can set Q1 is for minimum and then median and then Q3 and maximum, okay? So maybe here, like the box and whisker plot, it means like here we are using a straight line to represent for minimum and maximum. Then using a straight line to represent for median, and then it's for Q1 and Q3, okay? That is 5 lines right here. And interquartile range is from Q1 to Q3, okay? That is exactly value of here, okay? So that is it. And then we have comparing and data distributions. We can set first, we have an average, and most of the time we have the usually median, and also we have a measuring for a speed. Okay, so for example, like here is that the girls had a smaller interquartile range. Like here, is smaller than 25, meaning their scores are very close to each other. Okay, so we can set smaller interquartile range means all the grades or the values are very close to each other. And a very high interquartile range means that the data is distributed into different parts and they have a very far distance with each other, or the distance between the values are very far apart. Okay, that is it. So for example, like here, the deliberate practice I'll take you to do together for these problems. So first is that 12, 15, 18, 20 to 22 or even to 45. First, to state the number of values n and calculate the position of Q1, the median, and Q3. So we can say here, n is the number of values. So 12, 15, 18, 20, 22. We have already for five values, 6, 7, 8, 9, 10, and 11. So we can say here n equals to 11, right? And the position of Q1, median, and Q3, because that median is 11 plus 1 over 2. That is the third data, right? And Q1, oh, sorry, it's 60 data, sorry. This is 6 data. And here is 11 plus 1 over 4. That is for the third data, right? And here is for 11 plus 1 over 4, 10 times 3. That is a 9 data, right? Okay. So we can say the value of Q1 is the third data, that is 12, 15, and 18, right? So Q1 can be written as 18. And the median value here, because that is for the six data, that is 1, 2, 3, 4, 5, 6, that is for 25. And Q3 means 9 status, right? So we can draw Q3 for 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 35, right? So Q3 is 35. And for problem 3, to calculate the interquartile range, IQR, we can say here, just using Q3 minus Q1, right? That is the interquartile range. So Q3 here is for 35, we have already calculated this, and Q1 here equals to 18. So 35 minus the 18 equals to 17, right? So here we can say 17 is an interquartile range for this. And fourth problem is to sketch a box and V-square plot. So maybe here, let's draw it together, trying to understand it very totally, okay? So we can draw it like here. It's from this, and then we draw a box and V-square. And this is for 12, right? And this is for 45. So we can draw it represent for 12, 45. And median we said is a 6 status, right? We already said the data is 25, right? 25. And it is 18 right here. And also 35 right here, okay? That is for the box and V-square plot. So each data is represented for the exact values, okay? So the fifth problem is to the second data has a median of 20 and IQR of 5. And here you can find the IQR is for 17, right? IQR of 5 and 20 means maybe here is this graph. Like here is a very small IQR. And compared to the first data set, we can say here the data are quite close to each other, right? It has a very small IQR, means the distance or the value differences between each part has very, very small values. So we can say, oh, maybe the scores of them are very close and there are very small distance between each other, okay? So that's the data right here, how we can understand it for how to calculate and how to compare with each other, okay? So that already is our lesson. I hope you can understand how to calculate the quartiles and find the differences between different data, okay? So that is for today's our lesson. See you next day. Bye.